This is the screencast for section 3.1, example 1. In chapter 2, you found the instantaneous rate of change by finding limit as h approaches 0 of the difference quotient. Well, we're doing that same thing here in section 3.1, it's just now we're calling it a derivative. So that's your first calculus word. Oh my gosh, it's so exciting. So the derivative is that instantaneous rate of change. It is sometimes an equation form, sometimes a value. It is an instantaneous slope of the tangent line to a graph at point a comma f of a. So a comma the y value. So I drew a little curve here. I'm sure you can imagine that's a parabola. Here's its tangent line. The slope of this tangent at this point, a comma f of a, is the derivative. So the equation of a tangent line, like you found in chapter 2, would be y minus that y coordinate at a equals the slope, the derivative, which as you see we're calling f with this little apostrophe, that's called f prime. So f prime at a, the slope, the derivative at a, parentheses x minus the x value. So here's your point slope form of the equation of a tangent line. So to recap the three main concepts we've talked about so far in this course, a limit is when the y values from one side approach the same y value from the right side. That way your limit exists. That value does not have to be there, but the y values have to approach the same spot. Now if that y value is there, so if f of a equals that limit, now your function is continuous. Well, your function has a derivative now if the slopes from the left equal the slopes from the right. So we have the limit as h approaches 0 from the left and the limit as h approaches 0 from the right. So we are taking the slope of these two little points and we're approaching our specific a value to find the slope at that specific spot. So example 1, we're going to apply the definition of a derivative. Well, the definition of a derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. And we're going to find the derivative or differentiate f of x equals x cubed. So I need to, in the numerator, put in f of x plus h. So instead of x cubed, it's going to be x plus h cubed minus, and then that will just be x cubed. And then in the denominator, if you remember, this is really the change in x. So it's x plus h minus x, and those x's will just cancel out. So you're left with only h in the denominator. You don't have to write the change in x this way. You can just write h as long as you understand why it's just h in the denominator. So now I proceed to multiply out my x plus h. I squared it first, then multiplied a third one in. I get the first and last term to cancel, which is supposed to happen. I factor out, well, I divide everything by h, so I simplify by an h. Then I'm taking the limit as h approaches 0, so I'm going to plug in 0 for h, and that simplifies to an equation. That would be 2x squared plus another x squared, so that's actually just 3x squared. That is the derivative of f of x. So we can also call that f prime of x equals 3x squared. So if I want to know the slope of the tangent at 2, I can plug that in here. That would be 3 times 2 squared, so 12. If I want to know the slope of the tangent at 1, I can plug that in here, etc. The now try problem number 1 says use the definition, so the definition of a derivative, to find the derivative of the given function at the indicated point. Now we've looked at this a lot, but we're going to do it again. I need the limit as h approaches 0 of f of x plus h minus f of x, this is definitely something that has to be memorized, all over h. So I'm going to write my limit again because I haven't used it yet. F of x plus h in this case is going to be 1 over x plus h. And then f of x is just 1 over x, all over h. Now I know my a value is 2, so I can plug that in. You can choose. You can absolutely choose. You can plug that in right now, and then finish out your limit and just find the value at the end. Or you can find the equation for the derivative and then just plug into at the very end. It's up to you. Now I also know that I'm using f of x plus h, and this says use the definition f of a plus h. Well, this kind of gives me a hint that if you plug in the a value too, that would be easier. But remember, x and a are kind of the same thing. A is just a specific x value. So I'm going to go ahead and plug into and then do my calculations. So I found the derivative of the given function at the indicated point. I found the derivative of 1 over x at a equals 2, and that was negative 1/4. So the slope of the tangent line at a equals 2 is negative 1/4.